Hi, my name is Serge Dubrouski,
Marcello Barnaba.
and we work for Meta Platforms, where we are responsible for running Linux as a platform. We are sorry, our stuff that we are going to talk about isn't as cool as most of the stuff you've heard during today's. It's more routine work. Still, we thought that it might be interesting if we talk to you and present problems that we face and how we solve them. First of all, why OS is important. Nowadays, everybody talks about AI, buzzword isn't Linux anymore. But the truth is that under any AI, there is still Linux machine that needs to run reliably. What is the problem with OS management that we challenge? We have, right? What are the challenges? First of all, Meta doesn't own operation system. We run CentOS, which means it's completely external to us, and we have to deal with that. We don't control cadence, how often updates go there. At the same time, we have to make sure that machines, and we are talking about millions of hosts that we manage, gets updated on a regular basis because there is security requirements, there is policies, and so on and so on and so on. And we need to go to the latest releases not as soon, but with CentOS streams, the life cycle for versions is much shorter than for Red Hat, for example. CentOS 9 will be end of line next year. So what strategies, how do we solve those problems? Standard, image-based OS, automate everything, constrain OS life cycle, meaning that try to manage OS as a service. And to do that, we developed several tools. To some extent, some of them are open source, if you know how to run bug, because everything at Meta is bug targeted and bug built. And we are going to talk about those tools a little bit, right? First of all, OS snapshot, and the tools that we use to create them is called rolling OS updates. Why do we need them? Again, because OS is external to us, and we need to combine CentOS repositories, DNF repositories, with some vendors' repositories like NVIDIA and HP, Microsoft, with hyperscale repos that Davide was talking about a couple of hours before, and present it as a dated snapshot to two parts of our infrastructure. One to a host as a set of DNF repos through the standard DNF protocol, and another part to image build system as a buckified list of targets where every repo and every package can be addressed as a bug target and built as a bug target, and you can say that I want that package dated and predefined. So to do that, we defined major release like CentOS 8, CentOS 9, CentOS 10 as a set of DNF repositories with their URLs. Then every couple of weeks, we do sync up operation from external to internal. And when we do that, again, as I said, we upload everything into our internal infrastructure and make them presentable as a standard DNF repos and as a list of bug targets. We verify RPM signatures. We build new images, and images for services and for operation system bootable images. We test them before rolling them out into production. We have to test. Testing means re-image, rebuild certain set of machines into that new image and make sure that at least they boot, and ideally they can run production workload. Then those snapshots gets released to image build and to chef, meaning to production fleet. Another tool that we built internally is image builder that's called Antlir. As you know, there is many image building tool. Why did we need a new one? Basically, again, because we have very specific requirements. It has to be integrated with bug. It has to scale up. It has to be able to build format that are compatible with our infrastructure. It has to work fast, and that's why we created Antlir. Creator is here, Vinny Magra. If you have any questions, you can ask him, and he did presentation a couple of years ago on that. How does it look like, image definition in Antlir? It's basically Bezel code, Starlark code in bug. We define certain features where users can say that build my image, use such and such image as a parent layer, and then add a set of features. You can install RPM, you can enable systemd unit if you want to, you can create directories, you can do lots of different stuff building, and then you do bug build, and you get the image either on your local machine or build and upload it into our infra so you can rebuild the machine, server, test that image or install, or it can be integrated into CI/CD, and then it builds and goes to prod if we are talking about service images, for example. The main thing about this, the good thing about that all builds are reproducible and deterministic. Because we convert all those DNF repositories and RPMs into bug targets and check them into our source control, right? You can check out our source control code on any date or any hash. And you can build image, and you are guaranteed to get exactly that image how it was built months ago or a year ago. And it again was a real hard requirement for us that we have to have that feature. Images, they are OS agnostics, meaning that when you create a base image, you don't have to specify what version of CentOS you want to get there, 9, 10, 8. And only in the last one, you see here, we have like image layer, and then parent layer, and then we default, in the very last one, we say that it needs to be built as a CentOS 9 or CentOS 10, and we get it as requested. And using all those nice tools, we were able to create a product that called MetalOS, which isn't a distro, but a way how we run CentOS at Meta, how we package and how we deliver it into production. And Marcello is going to talk about that.
Thank you, Sergey. So, what is MetalOS? We have this North Star, that is what we want to build, is what we test and that we run in prod. And in order to do this, we need an elaborate and extensive image building subsystem, such as the one that Sergey presented. And this CentOS flavor is assembled from coarse pieces, such as UKI bootloader, and some of the work that we recently did ended up into systemd 257, such as the command line, the microcode add-ons, because we needed to load microcode very early in the boot process before other hardware was initialized. Then this bootloader is able to open up the control partition that contains, it's a single Btrfs file system that contains all the rest of the pieces of the OS. The bootloader then reads this well-defined host blueprint. We call the host config, that contains different parts, things such as the host identity, the host name, the IP address, or the root password hash, things that can change only when the machine is re-imaged. Then we have the boot settings, such as the kernel that the machine should run, or runtime settings that can instead be changed while the workload is running. Boot settings instead require at least a key exec. The goal of this is to have an OS that is as read-only as stateless as possible. So the machine boots, the UKI bootloader is initialized, open the controls partition, reads the host config, and finds out which kernel should I boot now. Then it kexec's into the target kernel that opens up the initRD that generates the configuration of the running system out of the host config itself and switches root into the rootfs. So you can change these pieces with either reloads or reboots or reimages, and you have a unified and coherent lifecycle that allows you to minimize as much as possible the on-host updates. Eventually, the last piece that as well has a config generation mechanism as well out of the host config is able to run service containers that are standard systemd exec containers with sandboxes defined into the systemd units. And these service containers are a step ahead with regard to what we were doing previously, because we used to run instead, say, log shippers or telemetry agents or other agents that we run on all machines all together into the same host OS. That is not great for isolation. Instead, we're going into a very long-running effort to isolate all these pieces so that they don't stop on each other's toes. However, this is all fine and good, but we can't migrate to this scheme overnight. So enter mClassica, that it's a metal frame for a classic OS. That is assembled from pieces defined in the host blueprint. We use the host blueprint to assemble the OS. We use changes to this blueprint to say change the rootfs that contains a new CentOS release, but it's still read, write, and stateful. So it allows the old chef recipes to install software, write configuration, and it's our migration strategy, because it's a big fleet with lots of teams and a lot of chef recipes around and things that have been done this way for more than a decade. So it's difficult, and I mean, it's a big effort to migrate. So how we update this? Because if we say we have an OS that is mostly mutable, we need to have a way to issue maintenance windows, drain the workload, and reboot the host to install new versions, or if not reboot, kexec. And like Santa visits kids with presents, we have trains that visit hosts with boxcars full of upgrades. And every host is visited every 45 days. We do this in batches, more or less each shared fate zone is visited at the same time. And we deliver fresh OS pieces. This is a way to deliver safely non-critical fixes. Say we have an incident, we put a mitigation, then we want a permanent fix, but we don't want to just SSH to the entire fleet and deliver the fix to all machines, because that would be unsafe. Instead, we say, okay, we're going to put this fix in the next version of the OS image, and we're going to deliver it because we have an established 45-day cycle. Or other high-impact upgrades, say systemd versions. We used to update systemd online while the workload was running. That is unsafe, and we decided to instead do that with maintenance trains. We contain failure, and if upgrades don't go as planned, there are automatic handbrake mechanisms so that they detect if the success rate is below a certain relative or absolute threshold, then the upgrades are automatically stopped. Still, we require a way to update hosts in place, because you can't just tell security that, hey, that fix for the 0 day is going to be released, is going to be rolled out in 45 days. So we still have Chef, but we are moving from a design in which we had Chef to do everything, that is first boot, initial provisioning, configuration, software management, and whatnot, to have two different agents. One is called host agent, that is mostly workload-oriented, so it takes care of what the products need, and MetalD, that is more OS-centric, and they both enforce life cycles and constraints to ensure safe and coherent upgrades. Further, these agents expose APIs to the control planes that roll out changes instructing these two agents. Now, where we're headed, we want to move more software and config management out of Chef, leverage these two agents lifecycle and constraints, and reduce the scope of in-place host updates and possibly stop the ROUs that Serge described, because we were in this scenario in which we build the OS image, we test the OS image, we roll it out, and then Chef changes the OS image, and all our tests are less relevant. New major releases as well, they occur every couple of years. They require some preparation for the base layers that build on the new major version, but the continuous provisioning cycles that we've established in reimaging the fleet periodically made these migrations safer and easier, because it took 15 months to move from CentOS 7 to CentOS 8, but then from 8 to 9 we took just 3 months. That is just 2 release cycles. Controlled rollouts with incremental switchover and baking, so we install a new thing and wait. Did everything break? Did something break, or is everything okay? Okay, let's move on, and have rollback mechanisms always in place. Reaching this 45 days goal required a lot of coordination. I was personally responsible for it, and my strategy was to first make everyone aware of the benefits and ensure the visibility. That means do project manager work and prepare dashboards with fancy graphs and things, so to convince people, hey, this is the right way to do. We worked together on regression, and we gently pushed back on requests to delay the cycle, proposing alternatives, because when people say that I am scared of this frequent reimaging, let's do it instead back to every 90 days, we worked together to make the updates safer and ensure that the requirements were satisfied. Of course, you need a buffer of machines that you have to use when you take machines out of production. You have to move that workload to machines that are idle and waiting for as a buffer. And if these buffers become thinner because of other incidents, then your cycle is going to be impacted. And as well, when you require technicians to go into data centers and you have to schedule manual work in data centers, that also is going to impact your cycle, because that takes a higher priority, because scheduling humans is something different than scheduling upgrades on machines. So there are many things to think when you have to work at this scale. Anyway, we were able in about 2 years to change the OS on 97% of this multi-million server fleet. We are able now to visit and reinstall hosts every 45 days. These images go under an extensive testing on our continuous integration pipeline that provisions real hosts, run real workloads on hosts, and verifies that everything is fine before releasing the machines to the maintenance trains. And basically, all CentOS 8 to CentOS 9 migration was automated code modifications. Now we are planning to migrate to CentOS 7 this scale, and hopefully we'll do that in 3 months. Thank you.
Questions? Comments? Yes.
Perhaps slightly OT, but can you talk a little bit about what you do in the hyperscaler SIG, and after all this work, if you are still happy with going with CentOS, or if you consider rolling something of your own?
Hyperscale and SIG, like David said, it's a version of software, technically upstream software, that we and our partners built ahead of schedule. There is stuff like systemd, for example, right? We have our own systemd team, which develops features, and sometimes they find bugs or add new features that cannot go upstream right away. So they build it and publish to hyperscale so we can install it, if that makes sense. Eventually, all of that will go to upstream. David wants to add something.
To answer your question, I think the hyperscale work is kind of orthogonal to this, and the idea with hyperscale is to try to do as much of the work we can as possible upstream, and I don't see that changing at any point in the future. I think we'll always have things like, for example, the systemd work we do maintain there. As for using something else outside of CentOS, there isn't really a reason to. I think if we had nothing and we were starting the company now and we were discussing which OS to use, we would have a conversation and that could go in many different directions. But I think even in a world where we have now, where we have millions of machines running CentOS Stream, we have established relationship with that community, we have processes and tooling and work tied in that space, I don't see a compelling reason to consider changing.
Other questions. I have a question. How many times per week does Dan ask you to switch to MKOSI instead of your build image tool?
Say it again, I'm sorry?
How many times per week do you get asked to switch to MKOSI instead of your own build?
Constantly. People asking why you don't use this or that or that. The thing is that we would love to, but to some extent we own legacy platform, huge legacy platforms that we cannot rebuild in modern way, right? Without getting into the world news with the headers like, hey, WhatsApp is down for 3 hours. And, you know.
Yes. Sorry for bringing you.
I will also add that whatever MakeOSI is doing would never, ever do what they need. Antlir is very much the right tool for the job.
And to make you happier, right? This is a fleet that runs services and technically internal. There is at least 2 variations of MetalOS. NetOS that runs on our switches, and now we built EdgeOS that will run on a corner. And those are more agnostic to new platforms. They built from scratch, so we are going to use more modern technologies there.
Are you running this all on bare metal hosts, or is this about VMs? And then how are you?
It's bare metals, but same. Antlir builds images for bare metals, for containers, for services that run on bare metals, including images for Twain and which is our scheduler for jobs and production workload. Right. The goal is that no service, user-facing service, runs on bare metal. They run in a container. Under our container management.
Okay. How do you do the re-imaging? Do you do A/B updates, like if you look at VMs or?
It's a total rebuild. If you're asking about bare metals, it's a total rebuild. Wipe out and install new initRD, install new rootfs, install new everything.
Okay. Thank you.
Mm-hmm. We have an entire net booting infrastructure. And machines come from the manufacturer to try to netboot first. Then they are going always to send the HCP request. But the HCP responds only to machines that are configured for netbooting. So when we want to reimage them, we configure them for netbooting into the netbooting infra. They reboot, and then they get an imaging in initRD that DDs the GPT image, and then inside that it downloads the other Btrfs send streams for the other pieces.
One quick question. I think you said that like 97% are utilizing this OS. Are the others just like, is that a haunted graveyard where you can't turn off a server, or what's happening there? And also,
it's long tail.
Okay.
It's long tail and might be special hardware. That's not, we haven't got to that LST, that type of hardware we are comfortable running of this. But we are getting there.
Other questions, comments? We have, oh yes.
Are you generally metal fans on a team, or the metal references are from the time when Phil was on the team?
You saw that we had T-shirts with that Metallica, Classica. We don't wear them today, but As you can say, I grew up on metal music, yes. Deep Purple, Led Zeppelin, and all of that, yes.
Okay.
Not Metallica, though.
I appreciated all the references.
And those antlers are for Antlir, because they are a similar spelling, so that's a Linux penguin with antlers, because it's built on Antlir and yeah, with a rock guitar.
Any other questions?
It was named before Mark renamed the company, sorry.
Sorry, that's all the time we have, so thank you to the speakers.